Mercury, the smallest planet in our solar system and closest to the Sun, has long fascinated astronomers and scientists. Despite its proximity to the Sun and seemingly inhospitable conditions, recent discoveries have shown that Mercury is much more complex and mysterious than previously thought. Recent observations from NASA's James Webb Space Telescope, JWST, have added another layer to the intrigue of this rocky planet. The James Webb Space Telescope, a pioneering observatory, has given scientists unprecedented insights into the composition and behavior of Mercury's surface and atmosphere. One of the most amazing revelations of JWST is the detection of previously unknown anomalies on the surface of Mercury. These anomalies indicate the presence of advanced geological processes that could potentially rewrite our understanding of the history and formation of the planet. Scientists have speculated for decades about the nature of Mercury's surface and its ability to withstand the intense solar radiation it receives. The planet's surface temperature can vary dramatically, with daytime temperatures rising to about 750 degrees Fahrenheit, 400 degrees Celsius, and nighttime temperatures dropping to minus 330 degrees Fahrenheit, minus 200 degrees Celsius. This extreme temperature difference, combined with the planet's lack of a significant atmosphere, made Mercury an object of intense study and curiosity. The latest data from JWST shows that the surface of Mercury is not as rough as previously thought. The telescope detected the presence of volatiles, including water ice, from craters in the shadow of the poles of the planet. This discovery is particularly surprising because Mercury is close to the Sun, which should theoretically prevent the existence of ice. However, constantly shadowed by the intense heat of the Sun, these polar craters provide a refuge where ice can persist. The discovery of water ice on Mercury has important implications for our understanding of the planet. This suggests that Mercury has a more dynamic and active surface than previously thought. The presence of water ice also raises questions about whether the planet has at least some form of life. Although surface conditions are extremely harsh, the possibility of subterranean environments where life could exist cannot be completely ruled out. In addition to water ice, JWST detected other volatiles on the surface of Mercury, such as sulfur, potassium, and chlorine. These elements are often associated with volcanic activity, suggesting that Mercury may have had significant volcanic eruptions in the past. The presence of these volatiles indicates that the interior of the planet remains geologically active and that the heat of the core drives the release of these substances to the surface. Mercury's magnetic field is another area of interest that the JWST discoveries have shed light on. Unlike Earth's magnetic field, which is relatively strong and well-organized, Mercury's magnetic field is much weaker and irregular. This irregularity suggests that the planet's core is cooling and solidifying at a different rate than previously thought. Magnetic field information provides valuable clues about a planet's internal structure and its geological history. The presence of Mercury's magnetic field also affects the planet's ability to maintain an exosphere. Mercury's exosphere, a thin layer of gas containing hydrogen, helium, and oxygen, is constantly replenished by solar wind particles and micrometeorites. JWST observations have shown that this outer atmosphere is more dynamic than previously thought, with seasonal fluctuations and interactions with the solar wind creating an ever-changing environment. The discovery of a tail of sodium and other elements behind Mercury orbiting the Sun is another exciting discovery. This tail, which extends millions of kilometers into space, is formed by the interaction of the outer sphere of Mercury with the solar wind. The composition and behavior of this tail provides valuable information about the planet's interaction with its spatial environment and the processes that shape its exosphere. The geological features of Mercury, such as craters, pits, and chaotic terrain, were also studied in more detail thanks to JWST. These features provide insight into the planet's violent past, including impacts from asteroids and comets. Craters on Mercury's surface, some of which contain glaciers, provide clues about the planet's history and the conditions that shaped it over billions of years. One of Mercury's most fascinating features is its craters, shallow, irregular depressions that appear relatively young geologically. The formation of these cavities is still a matter of debate among scientists. Some theories suggest that they are formed from the sublimation of volatiles from the Earth's crust of the planet, while others affirm that they are the result of volcanic activity. JWST's high-resolution imaging has provided new information that can help resolve these questions and shed light on the processes that shaped Mercury's surface. The chaotic landscape of Mercury, resembling a jumble of rocks and debris, is another area of interest. These landscapes are thought to be the result of ancient seismic activity that may have triggered the contraction of the planet as it cooled. JWST observations have provided new insights into the nature and formation of these chaotic regions. In addition to the surface properties, the internal structure of Mercury was studied. The high density of the second-largest planet in the solar system after Earth suggests that it has a large iron core. This core constitutes a significant part of the volume of the planet and plays a decisive role in its geological activity. JWST data on Mercury's magnetic field and surface composition provide valuable information about the size and state of the core and its impact on the evolution of the planet. JWST observations also raised new questions about the origin of Mercury's volatiles. Some scientists believe that comets and asteroids delivered these substances to the planet, while others argue that they were gassed up from within the planet. The presence of these volatiles in polar craters and on the surface indicates that the history of Mercury is more complex and dynamic than previously thought. Mercury's groundwater potential is another area of interest highlighted by the JWST observations. Although surface conditions are extremely harsh, the possibility of an underground environment where water can exist in liquid form cannot be completely ruled out. This raises the interesting possibility that Mercury may contain life in some form, or at least the conditions necessary for it. The discovery of the volatiles and water ice of Mercury also has implications for understanding the climate and habitability of the planet. The presence of these substances indicates that the climate of Mercury is more dynamic and complex than previously thought. This has led scientists to rethink the planet's ability to support life and the conditions that may have existed in the past. The JWST's observations have also provided new insights into the planet's magnetic field and its impact on Mercury's atmosphere. The magnetic field plays a crucial role in shaping the planet's exosphere and its interaction with the solar wind. The data from the JWST have shown that Mercury's magnetic field is more complex and dynamic than previously thought, with variations that suggest ongoing geologic activity. The findings from the JWST have also raised new questions about the planet's formation and evolution. The presence of volatiles and water ice suggests that Mercury has a more complex and dynamic history than previously thought. This has led scientists to reconsider the processes that have shaped the planet and the conditions that may have existed in the past. In addition to its scientific implications, the discovery of water ice and other volatiles on Mercury has practical implications for future exploration. The presence of these substances could provide valuable resources for future missions to the planet. Water ice, for example, could be used to support human exploration and the establishment of a permanent presence on Mercury. The JWST's findings have also provided new insights into the planet's magnetic field and its impact on Mercury's atmosphere. The magnetic field plays a crucial role in shaping the planet's exosphere and its interaction with the solar wind. The data from the JWST have shown that Mercury's magnetic field is more complex and dynamic than previously thought, with variations that suggest ongoing geologic activity. The potential for subsurface water on Mercury is another area of interest that has been illuminated by the JWST's findings. While the surface conditions are extremely harsh, the possibility of subsurface environments where water could exist in liquid form cannot be entirely ruled out. This raises the intriguing possibility that Mercury could harbor life, or at least the conditions necessary for life, in some form. The discovery of volatiles and water ice on Mercury also has implications for our understanding of the planet's climate and its potential for habitability. The presence of these substances suggests that Mercury has a more dynamic and complex climate than previously thought. This has led scientists to reconsider the planet's potential for supporting life and the conditions that may have existed in the past. The JWST's observations have also provided new insights into the planet's magnetic field and its impact on Mercury's atmosphere. The magnetic field plays a crucial role in shaping the planet's exosphere and its interaction with the solar wind. The data from the JWST have shown that Mercury's magnetic field is more complex and dynamic than previously thought, with variations that suggest ongoing geologic activity. The findings from the JWST have also raised new questions about the planet's formation and evolution. The presence of volatiles and water ice suggests that Mercury has a more complex and dynamic history than previously thought. This has led scientists to reconsider the processes that have shaped the planet and the conditions that may have existed in the past. In addition to its scientific implications, the discovery of water ice and other volatiles on Mercury has practical implications for future exploration. The presence of these substances could provide valuable resources for future missions to the planet. Water ice, for example, could be used to support human exploration and the establishment of a permanent presence on Mercury.